Good afternoon, everyone. Welcome to the today's Samvaad talk. I think some of you are joining on YouTube, and some of you are here. Will also be getting few more participants, hopefully. So it's my pleasure to introduce Professor Bernhard Thalheim and for our guest speaker for today. He is joining us directly from Kiel in northern Germany, and uh, so. Yeah. So Professor Thalheim, I'm happy to say he was my PhD advisor as well many years ago, almost 20 years ago now. So I'm here for almost 20 years already. So Professor Thalheim is from a town near Dresden in the former East Germany, and he's one of the very well-known researchers in conceptual modeling. He has made very important contributions to this field. In fact, he's one of the founders of the hierarchical ER modeling, which is also called HERM, which is now pretty much the standard modeling technique that is used in database design and converting from conceptual models to database models. And the conversion rules to convert them and so on. Professor Thalheim also runs the International Conference on Conceptual Modeling, which was earlier called ER Conference, Entity Relationship Conference, but now it has grown to become one of the most renowned conferences worldwide on conceptual modeling itself. Professor Thalheim's work is used in several industries across Germany and Europe and so on. For application design, and some of his students are working in several different, very influential areas across the world. So Professor Thalheim also comes from has a very interesting background as well. In fact, maybe after the talk, some of you might want to interact with him on his experience growing up and working in East Germany, and also his experience in Kuwait and so on. I remember some very interesting stories from there. So without much further ado, let me invite Professor Bernhard Thalheim to give his invited talk.
Thanks, Reinhard. I should say that Reinhard was one of my best PhD students, so I should give the compliments back. And now, as Reinhard, even I'm again back in Cottbus because I'm mainly now retired. But anyway.
Oh, you're back in Cottbus. Oh, okay.
And you know the house where I'm sitting and the place where I'm sitting now behind me is it's my room.
Oh, I see. Okay, it looked familiar. So
yeah. Okay. So I should now give a talk on conceptual modeling. Conceptual modeling is a pretty old thing. It is, in my belief, at least 4,000 years old, maybe even more, even older. In computer science, it started directly with computer science development, and for this reason, we should also look into this old work before we start to think only that conceptual modeling appeared with the famous work by Peter Chen in the first ACM journal. I will give you a little bit of my background. Here you have something of my background. You take this slide, please, as my restriction of my thoughts. I have this entity relationship orientation. We have had a handbook of conceptual modeling. There is a German book, unfortunately, but this is one of my best edited books on science and art of modeling in about 30 different scientific disciplines. That was a really nice thing. And when Reinhard was in Cottbus, we have had the task to earn some money, and then we developed websites, large websites, with something like 40,000, 50,000 pages. And of course, it was run by, let's say, some tools for generating these websites. This is an advance of conceptual modeling. The talk here will have a background. That is a paper we have been developing with Heinrich Meyer, the triptych of conceptual modeling. And the triptych contains mainly of 3 sides. That is the 3 panel. In the middle, you see, of course, somehow the concepts we are using for the conceptual model. With, of course, maybe some conceptual model, but we have 2 enabling panels. The left panel is our, let's say, support panel, what we have in our mind, what we have in our thought, what we have in our library. And the right panel is our language panel, because of most conceptual models in computer science are at least language-based. So this is now my advertisement, and now let's start with the lecture. I will go for the first part, and I call the first part the third eye. And I think you will realize in some minutes that it is really the third eye. We developed with my colleagues in Kiel, after 5 years or 6 years of discussion, a notion of a model. And we stated that the model is, of course, well formed, otherwise we will have problem to digest it properly. It should be adequate. That is what everybody says. Everybody says it should be there should be some mapping from some kind of origins to the model and from the model to other origins. We later realized mapping property is a little bit too general. For this reason, we should go for analogy. Often it is said it should be abstract. We realized it should be not abstract, it should be focused. And of course, it should serve its purpose. I think almost nobody really considers in a proper way is that we have to believe somehow in a model, and we should have a reason for believing. And the reason is that the model should be somehow justified. That is typically given implicitly. Justified means in this case, you should have a corroboration. It should be coherent and conform. It should be falsifiable, and it should be somehow stable. And the second part is it should be somehow usable. That means in this case, it should be of some kind of sufficient quality. And one thing what we typically don't do with models is to say which background we are using, which kind of grounding, which kind of basis. And for this reason, we are somehow not only neglecting, but at least not telling you what is in the background. These are, of course, paradigms. In computer science, we have a lot of paradigms. I will come also to them in some minutes. We have postulates, we have restrictions, we have also some kind of common acceptance. Some of you might believe, let's say for database models, that UML is a right thing. I believe that entity relationship modeling is a right thing. And so we have a different language and different, let's say, thought communities and different practices to use that. That means in this case, the model itself comes already with some hidden backpack. And for this reason, I think we should go a little bit into the philosophy with very old thing. Typically, computer science people start with some kind of triangle. This triangle is often considered as a triangle of Ogden and Richards. In reality, it is a triangle given already by Bolzano, and before that by Aristoteles. Twardowski was a pupil of Bolzano, and it says we have something like a language for expressing something. We have our thoughts about it, and we observe something. We don't see the world, we observe only something in the world. And then in this case, we have this kind of triangle in our world. That is what computer science people typically say. However, we have our thoughts not coming from nowhere. They are coming because of we are able to think, but because of we have already digested a lot. And this is my understanding now of the third eye. The third eye in your country is a very common picture, and it is nothing else as we have some kind of description we are using in order to use our thoughts, to express our thoughts. We understand what we see in the world, and it makes some sense. And in reality, we develop some kind of concepts. Maybe we should say not only concepts, we should maybe make a little bit finer distinction. I will come to that again in a minute. But this is now our, let's say, additional eye we are using here. Of course, in this case, we are somehow using models for a certain, let's say, usage spectrum. And for this reason, we have to say, okay, fine, we want to reflect a situation, for instance, what we have here, or we want to somehow to think what we should develop, or for interpreting, or for understanding, or for communicating. And then that means in this case, we are using this understanding of the world for constructing something, for problem solving, or for even organizing our social life. That means in this case, our third eye is somehow nicely supporting us in accepting the world. And there's something surrounding, that is what we bring in our sciences. In this case, we say, okay, fine, our models bring us what we should maybe systematically digest, systematically somehow summarize, and then we have something like a surrounding of our third eye and of what we have been seeing. Here I was already now looking for a different word than the word concept. Concepts are in most cases for conceptual modelers at least, codified concepts. It means we have a very nice, even something like a mathematical definition of a concept. For our expressions, we are using words and as references to something, and as would say, the concept in this case should be maybe called term. For our thoughts, we are using a little bit different thing. We have a rough understanding of something. We have maybe our own view on something. And then I say, okay, fine. In this case, I should call my mental concept maybe notion. In this case, we can now distinguish things. And then I say, okay, fine, here we have our entities, and the entities are what we observe, let's say, in our surroundings and what we are able to observe in a proper way. So that means in this case, the science is now becoming a comprehension, maybe some conceptualization, intellectualization. And in this case, our science says us what we have been observing and what are our thoughts about what we have been observing. That means in this case, we have maybe to consider at least the three worlds. The fourth world is engineering. There is a very nice saying that scientists think about the world and ask why. Engineers think about the world and want to develop something what does not yet exist. And they ask, why not? That means in this case, we are using our thoughts in order to develop something. That means in this case, we are active partners. So we have now this kind of three eyes representation here for our, let's say, understanding what is really a model. I should also define what is a conceptual model in a minute. So the first thing, however, we should maybe have some understanding what is not yet a model or what is a model and how we can, let's say that something is really a model. So in this case, we should have some demarcation saying what is a model and what not. We should also say what is the essence of a model, and I will show you that the essence of a model is that it functions in certain application scenarios. That is an old thought already Wittgenstein had about 50 years ago. He wrote it down. A model should function. And in this case, we should say which scenarios are of importance and which scenarios are, let's say, even taken in a stereotyped fashion. And then we can say, okay, fine. If something is not proper functioning, then in this case, it is not a model that is useful, at least for this scenario. In this case, we have to describe what means functioning. And we have also to describe how to use the function description for the model usage. All these nice red points are research tasks. And I would like to ask you to join this research, to join the discussions, maybe also in my international club, or if you are able in German, then please in German as well. But the German club will be a little bit late for you. It will be, we started 5 o'clock in Germany. That means it is going towards midnight in your country. So one thing, however, I should also somehow state, there are many notions for the notion of conceptual model. I know so far, if I go for, let's say, serious and good papers, about 60 different notions. Which notion is the best? Which notion is the most effective, the most appropriate, the simplest one? We can quarrel, and this will be only a religious war. And for this reason, I think we should maybe try at least to agree on what should be a conceptual model and what is not a conceptual model at all, or what is not yet maybe, or what is not even a model. Okay, I brought here some of the notions. Oscar Pastor made a keynote in ER 2016 in Japan and said most models are conceptual models. Of course, he could state that because of his world is mainly consisting of conceptual models, and for this reason, you could say, okay, fine, I like it. In the Handbook of Conceptual Models, we have been struggling with a notion. In 2011, we published a conceptual model is about describing syntax, semantics, maybe sometimes pragmatics of a software application at a high level of abstraction. In Wikipedia, you can also read something about the notion of conceptual model. Everybody has a different view. And in this case, we should say, okay, fine, let's try to have the sense of what means a conceptual model. In reality, if I try to structure all these different definitions, I come down with 7 different observations. One is that a conceptual model is somehow considering reality and world description. With Platon, we know, however, that we have no chance really to see the reality. We only observe something from the reality. And in this case, a conceptual model is something like the activity of formally describing some aspects of the physical and social world we observe that is around us for the purpose of understanding and communication. Or we have a community description made by a community like the entity relationship community, and you will find in the old version, that was the version until last year, what is a conceptual model in data, in the data perspective at least. Or you might have a conceptual database modeling approach. A data model is a collection of concepts. Okay, some more. One is, it is instance integrating conceptual modeling, or it is system representation models, or as representational models. These are essentially somehow similar, and it can be also given as one category. Some more, you have enterprise modeling and conceptual modeling, holistic conceptual models as an activity. My goodness, now you will get a little bit, let's say, falling into depths. Do we need all these different notions? We have some more. Essentially, these are 7 categories, but these are, let's say, the most accepted notions of conceptual models. I will give you my view and the view we have been developing with Heinrich Meyer over a longer time, and you will see that all these different notions are somehow specific forms of the general notion. You see here also that according to the introduction we have been making for the model notion, no, where it is at the beginning, yeah, where I said a model should be adequate and should be dependable. Then in this case, you will see here now which different parts and pieces are considered for the different, let's say, views on a conceptual model. Our big claim is that models have to be useful. They don't have to be valid. Our models about the world we observe are never really completely valid, but models should enable us to do something. That means in this case, models should function as something what is really useful. And in this case, models should function as instruments in scenarios. And in this case, we should now define what is a function, what is the purpose, what is the goal, what kind of essential parts we have at least to know about a model we are using. I would call it cargo, according to Bernhard, and in which case we have at least a chance to use a proper model, and this will be somehow the description of capacity and the potential. Okay, so far we know 5 different ways how to use a model. One is we use a model for problem solving. There's a very nice book about mathematics of problem solving written by Poja, an Hungarian mathematician. He made nothing else as defining a mold or a general methodology how to solve a mathematical problem. And problem solving is, of course, one of the big functions of models. Another is for engineering or for construction. That is a typical thing also for computer science. We use a model for description of our thoughts, what should be, let's say, at least in the database, for a prescription, what should be really coded, and of course, to check whether a realization finally is somehow working. We can use it for programming, for synthesis, for specification, and. That means in this case, we have very often conceptual models as engineering models. We can also use a model for understanding, for communication, for learning, at least for exchange of our thoughts. We can also use models for somehow compiling empirical observations, and maybe we come down to a definition. What I learned from historical sciences is models are used also for human life, for socializing. That is the book I have got now from Srinath. The main essential part there is that we are using models also somehow to organize our life in a proper form and to understand what goes on around us. So for this reason, I claim that the most important thing is, before we start to consider a model, what is the goal, what is the purpose or the function? So far, I will take the three notions, goals, purposes, and functions as not definable, as not defined. I will define it in a minute. But let's look on some pictures. You see here a model of a castle in Japan that is never built, but it shows how to build a castle that is somehow resistant against earthquakes. Or you might have a model of a building. Or you might use a model for system construction, let's say for a database system or for workflow system. You can also use models for communication, for fault prevention. In some parks, you see some pictures how not to behave with animals, or be careful, please. That is again a Japanese picture. Or you might have models for easy explanation. I use here the mathematical, let's say the easy explanation of what you see in the windows in front of restaurants, where you see which kind of food is somehow prepared at which price. You can also use models as visualization models, as very nice and very skilled visualization models, like I show here for a classical problem in geometry. That was a problem people have been struggling 150 years ago with a claim that the local minima determine the global minimum. There is a very nice counterexample and a very nice picture or figure for this counterexample. And you see again, we are using this in order to understand that, of course, this hypothesis was not true. That means in this case, we have a purpose, a function, or a goal for something that is used in some scenario. Okay, let's now try to define it a little bit more properly. Typically, or in many papers, goals, purpose, and functions are taken as synonyms. They are not synonyms. A goal is something like we wish something to have. That means in this case, we are a component. That means in this case, it is a ternary relation between the state we have so far, let's say the initial state, the final state, and the community of practice. A purpose extends a goal by means, by methods, by instruments, so that we can use a model. And the function relates the purpose to the scenario in which the model is used. Wittgenstein called it at that time application game. I like it still, but the function is really the most important part, why we are using a model in which understanding. In database area, or in computer science especially, we use conceptual models in two different scenarios: as a description of what you want to have, and as a prescription, what is a blueprint for constructing of another system, of another solution. And for this reason, a model is in this case used as a mediator between our thoughts, maybe our description, and our realization. In this case, the concept should be far better defined than in our imagination what we would like to have. A descriptive conceptual model is nothing else as, of course, an adequate and dependable instrument, but in this case we say, okay, fine, it is somehow delivering an understanding, some kind maybe of formalizing. That should not be mathematical formalizing, but formalizing. It should be somehow acceptable and without any conditions, hopefully. It should maybe also used for understanding what we see, what we want to see, what we want to have. Whereas a prescriptive model adds a little bit more. It adds how to construct a system. That means in this case, we should look into which environment we are going in order to realize our thoughts. That means in this case, of course, we should have some kind of blueprint that is really ready to apply, that is really unconditionally acceptable, that is really precise, and at least provides also some kind of explanations. That means in this case, we have now maybe a very different picture how a model is used. We have a model in the description scenario. In this case, it is used as, let's say, some kind of analogy of what we see, what we want to have. The focus is, of course, depending on our interest and on our local perceptions. And purposeful means in this case it should be understandable, negotiable, maybe it should be nice, beautiful, maybe we should use some kind of harmonization. Dependability is a little bit more complex. The justification is, of course, given due to the origins we are using. Origins are, let's say, the original parts which we are using for developing our model. It should be rational coherent. That means in this case, we should have some kind of representation of local viewpoints as well. It should be, let's say, validatable or testable against origins. That means in this case, falsifiability is again a very specific part. And it should be, of course, stable, so that we don't have to change our model all the time whenever a little tiny detail is changing. And we have quality in this case. We can use what software engineers have been developing for distinguishing different quality characteristics. And in this case, we have a quality in use for our instrument, that means our model. We have some kind of external quality and we have some kind of internal quality. And we should never forget that we should be able really to state the quality. For this reason, we should have some kind of evaluation procedure. Maybe within our algebra, in this case, we have to extend, let's say, the entity relationship model by some kind of algebra as well. If we go for the prescription scenario, the picture changes a bit. It changes a bit because of the model must be now as precise as possible for our realization. That means in this case, we are reusing the description model as one of the origins. And in this case, the justification is inherited partially by the description model. For the prescription, we don't look so much into the, let's say, very, very broad analogy. We want to have some kind of mapping property. That means it should be homomorphic representable within the code. In this case, of course, the focus is, of course, now based on what we want to see. For database models, for instance, my focus is to have models for the general, let's say, system. And we want to have also models for the users that want to use our database system within their specific application portfolio. So that means in this case, the picture and the properties change a bit. And now you see what we have been doing with our notion of models here. We said it should be adequate and dependable. And these are parameters that can be specialized according to the kind of model we are considering as an instrument that is functioning in a scenario. So now we can try to boil it down to the notion of conceptual model. Maybe the general notion is a little bit too general. We should maybe look what we can use in this case. I have for you a slim version first. The slim version says a conceptual model is nothing else as a model that is enhanced by concepts. That is a little bit too slim. You could say, okay, fine. Better it is to have something like a conceptual model is a concise and function-oriented consolidation of maybe perception and domain situation models. That means in this case we are using already models. In simulation, it's often said a conceptual model is a concise and precise consolidation of a goal-relevant structural and behavioral feature of a system under investigation presented in a predefined format. Maybe this notion is also a little bit too fuzzy, and for this reason I have for you also a concise version. A conceptual model is a model that is enhanced by conceptions from a conception space, is formulated in a language that allows well-structured formulations, is based on our mental perception domain situation models with their embedded worlds of conceptions, or maybe only concepts, and of course is somehow made according to our specific habit. Let's call it matrix. That is somehow accepted. The matrix is nothing else as some kind of canonized form of usage. Of course, with some kind of injection of what I call later the deep model. Okay, I told you already, for concepts, I would like to be a little bit more precise. And for this reason, I would like to have a little bit more or better notion of a concept. Classically in philosophy of science, classically also in our computer science research, we had a very strict notion of a concept. A concept has an extension and an intention. The intention describes the extension completely, and the extension is the only one what corresponds to this intention. That means we have some, we call it Galois relationship between intentions and extensions. I consider this as far too strict. That is true for our codified concepts, but not true at all for our thoughts or even for our language notions. For this reason, we should have a better notion. There is a very nice book, The Big Book of Concepts, written by Murphy. That is not the Murphy with the Murphy paradigm, but that is a philosopher who wrote almost 1,000 pages of what is a concept, but he was mainly using this very strict mathematical notion. Let's say we have, for instance, concepts worlds. Take, for instance, a person as a heuristical representation of a human. It is maybe identified by a name, Bernhard Thalheim. When I was in Kuwait, my name has changed to Abu Konrad. Or the name of my younger son has been changed to Klaus ibn Abi Konrad. The identification might change. Whether the name is a proper representation, you can judge on Andras Molnar in Hungary. It is of course Molnar Andras. Or you might have Oscar Pastor Lopez. Or I was using here one of my co-authors from Sri Lanka, American. That is a completely different name. Or you might say, oh my goodness, we should have only 3 or maximum 3 first names. Oh, we have a lot of people who have far more first names. You can add titles. You can address a person, let's say in Japan, by Kyoki Sensei, and you have in mind a professor that is, in the passport at least, Yasushi Kyoki. That means in this case already our identification of concepts is a little problem, but it can be solved if you have in mind the application in which you want to use it. You have classically, whenever you are talking about concepts and their properties, a little way how to construct a concept. You should say which feature is typical. which feature is really relevant and which feature is important. And in this case, you might have some kind of constructing expression, given your language, of course, so that you can use a combination of these features to characterize concepts and to model concepts. We should maybe also distinguish a concept from a conception. In philosophy of science, a conception is often defined as a system of explanation, whereas a concept is used for a classification. And we should also distinguish conceptual modeling from conceptual modeling. One is developing concepts, and conceptual modeling is using concepts in order to develop a model. For this reason, I was putting this slide here in order to be a little bit more precise. Okay, so what is now a concept in our modeling world for conceptual models? Everybody of us has her thoughts about the world that is surrounding us. That means we have some kind of mental world of a person. This is, of course, structured according to the culture, how we have learned to structure the world. It has also some implicit and some explicit structure. It is also maybe representing processes in an implicit or explicit way. In India, you are better with a representation of concepts, of processes I have seen. And you have also some kind of conceptual structures that allow us even to develop some kind of understanding what is a conception for our needs, our purposes. And in this case, you are using, of course, your specific understanding of the world. That means your paradigms that are somehow supporting the model. If you go, let's say, to dictionaries, you will find a lot of different definition structures. I love WordNet as maybe the best linguistic project we ever have had in the world. And in this case, you see here a long line of different ways how to define the notion of a concept, of a conception, of a construct in WordNet. These are synonyms, and how to use them in a proper way. Okay, let's now go for the way how we can conceptualize a model. A conceptual model is in any case a model. And I think we might use a nice word that was used at that time when we have been complaining that Web 2.0 is not a semantic web, or 3.0. It must have some kind of semantic interpretation. And it means in this case, 3.0 should be taken as a semantification of the web. Maybe I should use these words for semantification, semiotification, or simply sophistication of the model in this case. We have in our area a very nice trial to standardize the use of models and conceptual models. That was an ISO group, and Gruithuisen was compiling it and said in the compilation, a conceptual model should also include conceptually relevant concepts or aspects, both static and dynamics, of the universe of the course, thus excluding all aspects, external or internal, data representation, physical data structures, and access, as well as all aspects of a particular external user representation, such as message, formats, data structures, etc. That was a trial at that time with the understanding of, let's say, the 80s, what is a conceptual model. A conceptual model deals with the aspects, at that time, with the universe of discourse. Nowadays, we know that it is not the universe of discourse, it is our understanding, our observation of the universe of discourse. Of course, without implementational aspects, I think we have to change this as well. and representing maybe very complex structures, but only having one representation in a natural way based on our language, with some kind of specific value, added value especially of the model. And maybe we can use also examples from the user domain and represent the normal case without neglecting other cases. This led to 7 fundamental principles. I changed the principle a little bit. As a 100% principle, the 4th principle is not really a, let's say, a good goal. You should have something like 90 or 80% only. You have the Helsinki principle, you have the onion principle, you have the 3 principles. I think I should hurry up a little bit, and for this reason I will not go into details too much. We have a number of sorts, a number of things we can reuse for our conceptualization. We have, of course, dictionaries of different forms. We have maybe compilations of our world, what we should observe so far. We have our thoughts, we have our observations, or maybe we have only something like the analogy of a cave in Plato's manor, or the skilled third or first eye Egyptians have been using. So in this case, we can ask ourselves, are entity relationship schemata conceptual models? Oh my goodness, now I will destroy my old book. I will tell you that ER schemata alone are not conceptual models. We have to add something. Let's look first how we use, let's say, a conceptual model in our, let's say, area, in the database area. We have communication and negotiation scenarios where we try to negotiate with the customer or the business people what is now given in our data structures. We have a conceptualization scenario, we have a description, so compilation of what we have agreed so far. We have a documentation scenario. The entity relationship model has in reality been introduced as a documentation model of a relational structures. It was a little bit too complex to understand, and for this reason, we have been using this kind of documentation scenarios for our purpose. Here we have other scenarios, and in this case, we have a very special thing. We observe now that we are given a database schema and additional viewpoints or views on top of the schema. This is nothing else as a local as view paradigm of modeling. That means in this case, we should say, okay, fine, I have an entity relationship schema plus something that allows me to represent the views. Classical relational views say that is only a one table representation. My personal view might be a pretty complex entity relationship schema again, based on maybe the global entity relationship schema that is somehow providing me the data. That means these scenarios, I have now very different things to represent. The description scenarios, I should in the description scenarios, I should represent the viewpoints of business users. In the prescription scenario, I should represent how a database system is in reality somehow implemented in my, let's say, object relational database management system platform. I should have maybe also explanation scenarios, what can be found, what can be requested from a database. I mean, in this case, I should consider all these different scenarios in order to tell you what is now really a conceptual model and what not. In this case, I can say, okay, fine, in a conceptualization scenario, I have, of course, a conceptualization of my database application. Of course, representing the phenomena of interest. Of course, providing a means for analysis of main constructs, and focusing only on the relevant part and not on something special. That means in this case, a conceptual database model is now, in this scenario, nothing else as a database schema, plus a collection of complex views for support of business users. Plus, of course, a mapping so that I can have at least some kind of treatment, plus my declaration of model adequacy and dependability. In the documentation scenario, I have something else. My origin is now something that should be documented. That means I have a database schema. I have an association to the origin, for instance, the relational schema. I have a collection of views. In this case, these are typically relational views. That means in this case, we should now consider whether a relation alone is really representing a viewpoint of a user. But we should say, okay, fine, then I have a number of views for supporting the viewpoint of a business user. And of course, I should have a collection of operating structures plus an interpretation of the origins by our concepts, since we are using now concepts in order to document what is the meaning, for instance, of a word like name. And we have, of course, a declaration of adequacy and dependability. Oh, we can now go for description scenario. In the description scenario, I'm using the model to say what, why, where to, for when, for which reason, wherefore is my model used. That means in this case, I have again a database structure. I'm using still the local as view approach that is representing the global viewpoint on my database. Plus I have a collection of views for the support of business users. And in this case, I have now somehow, let's say, accepted reality models I'm using as origins that should somehow be taken as the source for my description. Again, I have a database schema, let's say in the entity relationship form, plus views. These views are not relational views, they are again maybe schemata, maybe in the entity relationship language. And I have again a declaration of model adequacy and dependability. In the prescription scenario, I should also add something that tells the implementer how to implement my thoughts. That means in this case, I have something like a realization template. I think most of you are programming, let's say, in C or C++. And in this case, you are using two very important things. So these are directives, that is something like a directive for the compiler, and pragmas that are used for pragmatic, let's say, interpretation, pragmatic generation. And in this case, we are using some kind of realization templates. Again, we can do it for the database structures. We use some kind of thoughts how to represent, for instance, a list, or what is a list of first names. Has the first name a meaning? Maybe it is a name we use for calling a person. In Germany, we are doing it so, and this will be very difficult if you come from a different country to Germany and you have the second first name used as the name to call you. But anyway, we have some kind of realization templates again to tell now our implementer how this should be understood. And of course, we have again a declaration of model adequacy and dependability. I claim that I need to ask you for research, maybe researching together even for a proper theory, maybe a proper culture of conceptual models. And for this reason, I should also tell you something about which open issues we have to write a paper, to write a master thesis, to have a paper in a good conference. For instance, also we have still until the end of this month the call open for the EJC, the European Japanese Conference on Conceptual Modeling, or even for the Entity Relationship Modeling Conference. The call is already open. So please come and research with us. What we need a very good linguistic foundation. My claim is that Indo-European languages have been a good starting point in the past, but other languages can contribute a lot. I was doing it for Japanese language, and I found, my goodness, this is a lot of thoughts, a lot of approaches that can be directly injected into our conceptual modeling approach. The same can be done with Semitic languages. And for this reason, maybe we should research for a proper linguistic foundation. Furthermore, modeling methodologies have not really reached the highest level of maturity like we use in ISO software standards. We have a modeling methodology, the co-design methodology, that is the first one that reached level 3. Other methodologies did not even reach level 1. Furthermore, our world is nowadays distributed, and we are using programming in the world that is completely different from programming in the large or programming in the small. And for this reason, we should also research what means distributed, federated database systems. Ontologies can be used for harmonization of viewpoints, but maybe we have to extend it somehow. Nowadays, we consider our systems as service systems or as embedded systems, and we have to ask how we can develop the systems in such a way that they can be used in a standardized way. Remember, in civil engineering, we developed a number of standards, and then our systems became there, pretty easy to maintain, with, let's say, screws produced in India for machines that have been produced somewhere in the US. And we need also a good approach to somehow to map what we want to know. Let's say if we are able even to formulate a question, that means to map the question to a query. This can be done, of course, with a good number of compromises, depending on the platform you are using. And in this case, typically with a question, you provide also the form of an answer that should be given. That means in this case, you might have a chance to map it. We did it together, at least we developed a proposal in the EGC conference last year with question-answer forms. We have a number of goodies, what we really developed. Data modeling is still an art, has not become yet a culture, but we have at least parts and pieces for that. Model transformation is, in my understanding, near to be closed. Co-evolution is at least for the current platforms solved, and we know how to apply model changes. But we have also closed issues that were, in my understanding, somehow, let's say, thoughts we have, or dreams we have had, like interoperability. They will be never somehow possible to solve. Also, we had a lot of thoughts of what is knowledge. Nowadays, we know that we even are not able to define the notion of knowledge. We are able to define the notion of information depending on our community of practice, community of business users especially, but nothing more. We have also, of course, a good number of really challenges, foundations, the model usage beyond the description, known agreement in a community of practice, how to map it, how to do it, how to handle it. We are used due to mathematical logics to a strict separation of syntax and semantics. In classical natural languages, we are never using such kind of separation, so we have to go beyond this separation. Maybe we have different means of abstraction levels. The OMG layering of languages is a nice tool, but far away from being universal. So far we are using global as design. Maybe we should change to local as design and to harmonize the different, let's say, thoughts, viewpoints of users in a proper form. Yeah, there are a good number of open issues, AI, machine learning, maybe data science, and I think this is a longer list. I should continue for another 2 hours, maybe, if you give me this time. We have agreed on something like 30 minutes, 60 minutes, so I should now start somehow to summarize things. Okay, what we have so far or what they should have. So, in the next is maybe a flexible model transformation. We should also look for large data models. My largest in my collection, I'm collecting still entity relationship schema solutions. My largest data model I have in my collection is consisting of 90,000 attribute, relation, and relationship types. So it's a pretty large, and of course not available by only one human in one shot. Sometimes data are weakly structured. Data come typically with provenance and with quality, and we should somehow have this kind of manageable quality and provenance integrated in our models. We should also be, let's say, having an adaptable, self-adapting. Maybe we should also toughen our data model. We have, we call it often legacy applications. I call it heritage applications. And we should extract the heritage. Just-in-time data models are the usual thing in most engineering, also in most social science disciplines. So we should maybe have also an approach for that. Data models reflecting storage in a proper form, independently, of course, on the platforms. That means in this case, we should have some kind of even platform independence of our models. Special data models for special tasks. We have also a lot of people who are developing a database application, not having any kind of background in computer science or computer engineering. I call these layman data models. They are very useful, at least for the application, as long as the developer is in the community of users. We should also harmonize things. Maybe we should go for a standardization, similar to industrial development in the 19th or even 20th century. We should use maybe generic conceptual models. That means, again, we have a number of good issues to handle somehow. If you want to read more, please go to ResearchGate or to academia.com. Read some kind of collections. I have so far 3 collections of papers. 2020 and 21 collection is not yet ready. 21 is still 9 months to go. So I will make the next collection only available at the end of this year. You can read something about my thoughts. Remember the books I gave you in the beginning. That is my restricted view in the world. Okay, and I think I should now be open for a lot of questions you can ask.
Thank you, Professor Thalheim. We have quite a bit of questions coming up. Professor Dinesha has a slew of questions.
Good afternoon, and thank you very much for this talk. It's really a wonderful experience to sit through this talk. Okay. Actually, I had lots of questions. That's right, because as and when I was listening to your talk, I was getting questions. But only one thing is that I have put them in the chat. Okay, so maybe I have to see the chat and then ask the questions back to him. Probably at that time I remember the context. Okay, so
would you like me to read them out or something, or you can also?
I have in the chat this description, the description model.
Okay. So 1 minute. I'll start from there.
Yeah. The description model is, in my understanding, nothing else as a trial somehow to represent my thoughts, my my imaginations, even my models or my worldviews into my model I'm representing now. So this is nothing else as some kind of compilation of my thoughts, of my background into one model. You say UML seems to address the aspects. That is partially true only. In UML, you have a problem of selecting what is a lead model. The lead model in UML is often taken as a class model. Then in this case, you are restricting yourself to an object-oriented viewpoint. In reality, your world is never so object-oriented. That means in this case, you are already mapping, you are injecting a certain paradigm in the set. You can also say, oh, no, 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 I want to have, let's say, some kind of process-oriented view at least. UML is somehow related to that. The problem is only the people didn't have so much in mind the conceptual models. They had in mind the software construction mainly. The software construction in the way how it was done, let's say in the 70s. And nothing else.
In fact, that brings another related question. Is it possible to have what is to express what is in my mind to exactly map to prescription? That is, like, for example, it's equivalent of telling that what do you call it as unambiguous system, I mean, requirements giving. Probably isn't it impossible?
My medical friends say, if you have three medical people together discussing about a disease, they have typically 6 different opinions to discuss instead of only 3 or only 1. And I think the same is also valid for our, let's say, understanding of the world. What we do typically is we let the people learn the culture or the approach of a company, and then we have already injected in a religious way even the thoughts how a company should run. And in this case, we can have some kind of harmonization. But in reality, the harmonization is a long story of negotiation. What I understand, what is a name, for instance? Is Abu Konrad a name from Bernhard Thalheim? Yes, in the Arabic environment, and it was written even in the protocols of the department meetings as Abu Konrad, until I realized that that was me. That means in this case, we should have some kind of common agreement, and it's very difficult, let's say, to have it. The good thing, however, is we are educated somehow or disciplined somehow. And in this case, we have a special way of approaching, let's say, a person or approaching an application. And then it means we are injecting our culture as a codified way, what we observe, our culture into our modeling as well. And your second question was, are there models to model regulatory requirements which we can integrate with requirements engineering?
Yeah.
Let's say the classical UML saying is yes, or the classical software engineering saying. My answer is no. Because of you should not start with requirements, you should start with application. And in this case, you have a very different way how a requirement, let's say, occurs. And for this reason, it's something like human wisdom, maybe what would be a good approach, a good methodology. For this reason, I like also this kind of notion of a mold. This notion comes from mathematics, where we how to solve a differential equation. We have typically 6 or 7 different ways how to solve a differential equation in an analytic form, nothing more. And this is a mold that is given for us, developed somehow for us. And the same is also valid for our, let's say, requirements engineering. And regulations, laws, and something like that. That is really a big issue, how it depends on what can be represented in which way. Think about simple things like privacy.
Maybe just to add a little bit, I was wondering, I think the question also asks about deontics. So you mentioned privacy, right? I mean, in terms of what ought to be, because both prescriptive and descriptive models talk about, what will happen, or but what should happen is where the deontics come in. So I don't know whether any modeling language kind of currently uses that.
I think we have here a problem of our computer science. Ethics is not our issue, never. Yeah. And it should become an issue, but we don't do it so.
Yeah.
It's a half answer, Ganesha. Sorry for that.
Okay.
And you have another question here. Is it possible to make the gap between description and prescription to 0. No.
Yeah, I think that was the
question. Different.
Yeah.
One is description, and the other one is to force you to have a specific realization. That is completely different, let's say, function there. And in this case, the models are, of course, harmonizable to represent in one model. I would, however, call it a model suite. I would say, okay, Faden, you have two associated, tightly associated with each other models. One is a description model, the other one is a prescription model, and whatever you want to use now, in which direction you want to go now, maybe one is a lead model and the other one is a slave model. Then there's a Srinath question to everybody. Is it always true that there is always just one extensional representation for an intentional model? This was a dream long time ago of philosophers. And whenever I was going to the philosophers and then I discussed with them, I realized that they were even very skeptic about it, but they said it is nice to have it. In reality, I have never seen an infinite set. Never seen in my life. I hope I will never see it. But extensions are typically infinite.
Infinite, correct.
So in this case, I have a problem. And my worldview is pretty simple. I can only digest maybe 5,000 words at the same time, nothing more. And even going over my model library, I have a lot of difficulties to understand what is there. Not having the application engineer with me. But there is another question by Dinesha. Can one ID represent a person for all purpose? Nowadays we think so, or Microsoft thinks so. But
but just a related explanation. Just a related explanation. See, normally what happens today because of the machine learning and things like that, if I use the same ID for 20 purposes, the aggregators can basically profile me, which actually violates the privacy one. So that's the context. I just asked that question.
Yeah.
So there is a contradiction between privacy versus giving one ID.
Yeah, privacy is nowadays an issue. Companies don't want to have it. I want to have my privacy. Whenever my people in Germany tell me we don't need privacy, I ask them, are you going to the shower room and making a video whenever you're showering? They say no. So they want to have some privacy. So I think privacy is also necessary, because if you don't want to tell everybody anything, you want to have something in private. Even your, let's say, your dreams at night, you want to have in private, and or your digestion of something. And if you would say to everybody very frankly what you think about somebody, then in this case you would have only enemies. That means in this case you need at least some, let's say, restriction. And
I have a somewhat similar question to this, which Professor Dinesha asked. So what Microsoft and software usually does is it associates an ID with a person. But we know from social science or cognitive science that we are not a person, but we are a set of persona. That is, for example, our persona at home would be very different from our persona at work, and our persona while traveling in public and so on. So we have a very different kind of interface, right? But then the ID is the same ID for all of them. So I'm the same person at home, and I'm the same. But should we actually have an ID with associated with personas rather than person?
Yeah, for industry,
I think that's another version of it.
Yeah,
it is an interesting one actually.
No, I think we have to go back to our classical cultures. In classical cultures, we never had only one identity. Of course, let's say if you put somebody in a grave in Egypt, it was only one identity you represent. Let's say the envisioned identity after life. But why you should have one identity? even let's say I have at least 3 different opinions whenever I have to make a statement about somebody. To my wife, I say it pretty frankly. To my friends, a little bit less frankly. But on the street, I would not say that the policeman is the most stupid guy I have seen. That is, that means in this case we have to have, let's say, also a way how to be more flexible. But for machines, okay, fine, we need it somehow. We should only restrict ourselves to not to become machines. And Srinath was asking, does the language we speak shape us the way we think and build conceptual models? That is unfortunately really true. There is a very good, let's say, reference for that. That is the work of Sapir and Worf. These are 2 linguists.
Mold hypothesis.
Yeah, they realized that the Hopi Indian tribes are having a very different notion of, they don't have a notion of a state, but they have a notion of change, and a really proper one. And they can characterize things by the changes that happened. And the same is also valid. I was learning Japanese language for one reason. I wanted to understand the construction way, how the language is built. And I realized that their thought is completely different. The same is also valid for Semitic languages like Hebrew or Arabic language. It is not representable by Indo-European languages. So in this case, our language is an enabler and a restrictor. Whatever we cannot express, we don't tell. That means in this case we have a problem. And this is, for this reason, we have also very different cultural, let's say, issues expressed by our languages. I see another question by
Milind.
Milind, yeah. Modern NLP approaches are almost purely existential. Yeah, that's right. Natural language programming approaches are based on our ability to use a language in a proper way. And I think it is almost impossible to have an automatic translator from one culture, treatment of one language, to another culture for another language. I compared quite often with translations for, let's say, Faust by Goethe in different languages. I realize all the time that it is very different from what is said in English or in Russian or whatever. I mean, in this case, I think it's a good thing that is almost impossible. Wittgenstein said, my language is my thought. I think that is not true. My thought is far broader, and also if I talk, let's say, to pianists, musicians, how they think about what they play. My goodness, they don't have an expression for that. So that is this melody in this very specific form. My goodness. Or think about the language of a chess player, of a good chess player. That is even not a good. That is even not represented by graphics. They have some kind of general picture how a game could evolve. I don't think that is expressible by a natural language. Maybe it is our understanding of neural networks is a little bit too primitive so far.
So can I just ask a follow-on on that, Professor Thalheim?
Yeah.
So there is, there are some fairly core thoughts that would get expressed very differently in different cultures, but the language and the language expresses them differently, and yet we understand those thoughts commonly across cultures. So as an example, when I speak to a Japanese colleague, I would say, "What do you think?" And he would say, "What is your image?" And yet we both know that when we are saying, what do you think, or what is your image, the intended question is the same. And how does one capture some of this?
This is a very nice question. I will, let's see, there are some people researching on cultures, on human cultures. And Richard Lewis has a very nice slide. I should search if you want to see it for a moment. What means no? What is the word, the expression of the German word no in, let's say, English or in Swedish language? And what is the expression in Japanese? In Japanese, no is very impatient. In Japanese language, you say, let's say, if you are you sharing the same belief? You're asking a Japanese guy there. He says yes, but you could think also a little bit different. He doesn't say no, it is nonsense. He says, oh yes, you are right, but for you, okay. That is a completely different meaning. And I think this is this to translate is almost impossible. Or when they have been delivering projects in Sweden, the Swedish people told us that is a good project, but the Swedish way is better. And this was a complete denial of, let's say, rejection of the project. So. So it's very difficult to translate it really in a proper form.
I have a kind of a follow-up question on that as well, Professor. So yeah, in fact, like Milind was also saying, I was noting how, for example, in German, to ask, what is your profession? You say, was machen Sie, right? And what do you make, and so on. But in English, if you say, what do you make, it means how much money do you get? So there are a lot of so are you basically saying that intentional modeling is not possible at all, or how does it relate to, for example, say artificial general intelligence or common sense intelligence, that we cannot achieve the common sense intelligence at all in machines?
I think it is almost impossible. Of course, we try it somehow. But maybe it is. Let me share you with you one slide. Do you see this slide? Communication, what is typically said, the British coded speech, and what is really meant. If a Brit says, "How could you say that?" then the meaning is, "I wouldn't say it so." Or you must have. We must have a meeting about your idea is the same as for a German, forget it, go home. That is a completely different meaning. And I think that is also a problem of conceptual modeling, why we have to have a very different way to express our culture. And that is injected, and our concepts are coming as mental concepts, as reference concepts, reference from the language, mental from our brain, what I call notion and term. And these are completely different from our very hard codified concepts. That is a pretty hard topic even.
Yes, this is a much longer conversation, Professor.
Okay, fine. I can tell you my Zoom accounts and we can have a longer discussion about it. I would like to have it.
Sure.
I would like to learn your approaches as well.
Sure.
One of my co-authors comes from Sri Lanka, and he tells me so many stories about my stupid thoughts that I say, okay, fine, I have to learn something from different cultures in a much better way.
All right.
I think next question also is somewhat similar, coming from Sanskrit. I don't know if Professor Prasanna, if you're there, would you like to ask, or shall I read it out?
That was coming from Srinivasa Prasanna.
Yeah. So his question is asking, is there any relationship of this to ontologies in languages like Sanskrit, where primarily everything begins with a verb root? So for a number of Indian languages, there is a a root in Sanskrit, and then which somehow is also somewhat similar to German in many ways.
Yeah, I think the problem, let's say, we should go away from the name ontology what we use in computer science. In computer science, is a trial to model something or to express a model of something, but this is not an ontology. An ontology in reality is some kind of classification, categorization of what we see, or what we somehow observe. And as in this case, we can say, okay, find this, for instance, something is living. The classical way is to say, okay, fine, living means in this case what we have been learning in biology in the 19th century. Nowadays, we know that bacteria and viruses are also living substances. My goodness, this is completely different. It means in this case, we change our ontologies with the cultures. And that is also a way, let's say, in Japanese language, I'm never using the word I. I is very impatient. Whenever I state something, that is stated by me for this reason, I don't have to use the word I. But if somebody refers to it, he should also not refer this guy and something like that. Not there's no direct way how to express it. That means in this case we have a completely different meaning how we use it. And again, that would be my proposal to discuss this issue with Sanskrit a little bit more properly. Sanskrit is what I have learned from the Sri Lankan people, how they are, how their thought is expressed in a special way. We have been discussing in a paper about models for medical, let's say, treatments. And I learned that they have a completely different way how to treat organs of a human. It looks for me like Eastern medicine. But that is a completely different observation world. And I think so, those things is, we have to learn it somehow if we want to do it in a proper form. With my collection of database solutions, I have a collection for about 90 different countries. On one day, I was sitting down to look which kind of typical mistakes and errors or faults are in their models. And I realized that I can categorize according to the culture what they are doing. And that means there is also some thought about what could be somehow neglected in their schemata. That is culture what comes in. And even the database schema look, let's say, in America, completely different from a German schema. That is funny, but okay. Maybe for this reason, international companies have a very bad life to force the people to think their way. That is maybe a problem. And there's another question from Dikabar. Also many. In the old Jewish religion, you say there is no universal world formula. God is the only one who can reason about the whole world. And I think that is the same here also. We might have very different models about anything. Even, let's say, somebody who works in physics has a very different world model when he goes to the university and a completely different one when he goes to the church. And they are somehow usable. And models are nothing else, that is my claim since half a year, nothing else as our third eye. I like it what you said in India with the third eye. That is my thoughts somehow expressed in a certain way. And this is my, and a model for this, and model-based reasoning for this reason is never deductive, or in most cases not deductive. And for this reason, that is your understanding of the world expressed somehow. I'm struggling with English language in this case because of German language is sometimes much more precise. We have in German language the word Auffassung and the word Vorstellung. Auffassung is what is my understanding, what is my feeling, what is the flavor I feel, or something like that. And the English translation doesn't work in this case in a proper form. And Vorstellung is what is my compilation of my imaginations. And this is, I think, these are the two sides what we have with models at least. And this is, okay, fine. I would call it now your third eye. I do not know.
So is it somehow intentional and extensional model? Is Auffassung intentional and Vorstellung extensional?
Of course, you can externalize a model in order to display it graphically or somehow in some way, in a language way. And this externalization is, of course, and you represent it for, let's say, for communication, or you represent it maybe for doing something. That is some kind of externalization. But in reality, your internalization runs with that too. You don't tell me only what you have in mind. That is coming together somehow. For this reason, I like this notion of a model suite, that you use an ensemble or a collection of models at the same time for very different, let's say, functions and issues. Maybe that's one of my medical guys. I wanted to understand how my medical people are reasoning. They have been there in intensive care. And then I was asking why you treat this patient this way. And in German language, she said to me, he is a Waschlappen. That means he is not sufficiently tough. And everybody agreed with this kind of model of somebody who is not fighting for himself. That is, that means this is a model for, let's say, for the treatment, and they have to help him somehow. And the treatment of this guy, for this guy, is a completely different one than for another guy who is, let's say, a tough fighter. But I wanted to have some kind of definition. What is this kind of, let's say, a person? I said, do you see it? I said, no, I don't see it. Yes, of course, everybody sees here. This is completely clear. I said, what are the signs? What are the observations? He said, no, we see it. That is the experience, the intuition, or something like that, what they have learned.
Yeah, in fact, I have a similar question about the idea of intuition. You know, I mean, how do we factor intuition into models? Because a lot of times we act not by models but by intuition. So how do we? Is it possible to codify intuition in some way, or either keep it like an oracle saying that okay, this is an open world and intuition, and factor that into the model?
I think we are only able to map what has been externalized.
Correct.
And your intuition we cannot map. Even you know, I have a good number of female PhD students, much more than a typical German professor has, and I love them because they have a very high emotional intelligence that goes far beyond any emotional intelligence I could have. And they say, we have to say it so for this student. I say, yes, clever girl, nicely done. I would never do it so. So it is some kind of completely different externalization. And there is a Nobel Prize winner, even Erich Kandel, who claims that we have 3 brains, not only 2. That is, I think modeling is mainly really, no, I call it now third eye. My third eye is helping me out of, let's say, situations, and then I have my model, and I can, if somebody tells me his model, then I can use his model as my additional third eye. So, and then there is a question about when there is so much of specificity in things, language interpretation, it is worth an attempt to generalize models. Yes, I think so. If you want to have a humanized environment. maybe Srinath knows how Germans. I know also. I have been seen all the time this movie from Hyderabad, how in Hyderabad traffic is going on, and how your traffic is based on some kind of communication and could not understand, but it works. I have been waiting on one of these crossroads for accidents, and I have been waiting for 1 hour, and I didn't see anything. If Germans would drive there, they would have immediately accidents each minute. That means you have a very specific way how to behave, and if you want now to have a support system for that, then you need to have a model of human behavior and traffic. And it's the same is also valid. Let's say if I go to US, I switch on my cruise control and I drive the car while dreaming about something else. If I drive the car on German highway, I have to be very careful about my neighbors who claim that they have higher rights for something to do. There is, and for this reason, they're also developing some kind of models. Models are also used for communication, and for this reason, we should know what is really the sense behind. And my claim is now that models is something like the third or fourth sphere of human activity. And mapped, of course, to the observations or the observable things, mapped to science, mapped to engineering. But anyway, we are humans, and then we have our thoughts about it. And it's not only valid for the humans. My cat has also a model of me and of my wife. And the cat separates very nicely how to behave with me and how to behave with my wife. My wife has to open the door, to close the door, to open the door, to close the door, and the cat knows that I'm lazy, and for this reason, there's no sense to ask me. So it means in this case also animals are developing some kind of understanding. So in this case, okay, but that is my, let's say, current way to understand the things. Maybe in 5 years from now, I will tell you the story in a different way.
Yeah, so thanks for a very wonderful talk, Professor Thalheim. In fact, I would love that we would have further discussions, especially I'd like to have your inputs on a lot of the AI-related work that are happening here, both on intentional modeling, on ethics, on regulatory modeling. There's so many things that are actually required, but we just don't have the at least I feel that the current way AI is going, it doesn't have the proper foundations in conceptual modeling, and many times we don't even recognize the need for a conceptual model in that, and let alone how different cultures view different models, and how models are culture specific. And so it would be wonderful to keep this discussion on in some way or the other. Maybe we can get back in touch with from our lab, and maybe other interested faculty members who are here can also join me, and we can have a more detailed discussion sometime going forward. So with that, let me thank Professor Thalheim once again, and thanks everyone for coming. And as always, we'll meet again next Monday for the next Samvaad series, and with Professor Thalheim, we'll form a separate group, and we'll have a separate set of meetings further on.
Yeah.
Thank you, Professor. Thanks for joining us.